Hi everyone, welcome back to the stream, the Code With Me live stream that we're doing here on the AKS community channel and through other outlets. As promised, today's topic will be the SBOM or software bill of material. And to be honest, I've spent, I don't know, probably the last day and a half kind of digging into it, trying to figure out what it is and how to add it to my pipeline. It's something that's been on my list since build. I got approached after my talk on a lot of these open source tools that you can use to secure your supply chain. And lady came up to me who works inside Microsoft and said, have you thought about adding the SBOM into your demonstration? And so that's kind of what I've been working on lately. To be honest, I have a few more questions than I have answers after the day and a half. But what I want to start with is um, kind of showing you the research that I found, and then I'll just add links if you want to. I'll add links to the video if you want to dive deeper into it. So with that, let me just share my screen, and I'll kind of just walk through my notes. And what my goal here is just to bring you as close to learning alongside me as I dive into these topics as I possibly can. And yeah, that's kind of the purpose of this particular live stream. So without further ado, let's go ahead and share the notes. And again, there's nothing fancy here. I'm just using logseek to kind of collect my thoughts. And if you like the outline of how I'm kind of collecting this information and using it, maybe you'd like to adopt something like logseek for your notes. But let's just take a look here. Make sure I get the right screen. Take a look. And then we'll switch. There we go. Make this a little bit bigger. How I usually do this is I create just a card. Well, I think it's called a page in logseek. So I can search for this with Control K. So I have an SBOM page. And really all I do to start is I just start putting in kind of the headings of the topic I want to dive into. And then I start asking questions. So if we look inside the SBOM, this is kind of what I want to skim over. I'm not going to read everything word for word in here. If you're curious to learn more about these, again, I'll put links to all of the stuff that I've been using, all the references I've been using in there so you can dive deeper. But hopefully what I've done is saved you from some very boring reading is hopefully the first 15 minutes. And great to see you again, Adam. Thanks for joining. Appreciate it. And yeah, save you some time reading. So understanding the software bill of materials is kind of my first goal with probably the first 5 to 10 minutes of the stream. So the first thing is, like what is this software bill of material? And if you're not familiar with logseek, it's block based. So what's pretty cool is I can just like go through all these levels of blocks that are in here. So the first one here, I can expand it this way, and you can see everything in one page, or I can just drill down into it, and it's kind of like a navigational node at that point. But the first question that I wanted to answer is, what is the SBOM? What is the software bill of material? And then that will lead to further questions. But the big gist is of what it is it's a formal record, typically in JSON or some kind of XML that outlines the relationships and components that make up your software. And the big reason here for this is transparency that we'll dive into in a little bit. But it's a formal machine readable inventory of the components and dependencies that make up the software in a hierarchical relationship. It's a difficult word for me, that hierarchical relationship that they have. And so there's some websites that I got this from here, the software bill of materials, and then at a glance. And these are mostly from the ntia.gov. And you might be wondering, what is that organization? Well, they're the ones that created the software bill of materials definition, at least the minimum requirements for it. And that's the National Telecommunications and Information Administration Agency. And it's interesting, the motive behind here. This isn't really anything that's been driven by the industry itself. It's actually been driven by uh, an executive order. So if we look at, let's just kind of skip ahead. Maybe we'll move this up to why it's important. So just to reiterate here, the software bill of material is going to be this document that lists out all of our components and the relationships between those components. So that way, when you go to a vendor or when you're delivering your software to a customer, they have some kind of an assurance of what is inside the software that they're consuming. And that's all, of course, to bring transparency to the software and to help reduce the risk and likelihood of supply chain attacks is the main purpose there. Oop, and I went back too far. So we talked about who invented it. Now I want to know why it's important. So the main reason why the software bill of material is important, and a lot of this is in its infancy. There's a lot of tools around kind of the left side of the process where you're generating it. There's a lot of options, to be honest, inside that realm of generating it, but it gets a little bit fuzzy as we get down the pipeline into the operation side, where there's a lot of unanswered questions, even in the industry, of what do we use it for? Like, how do we take advantage of this new artifact that we have? But the motivation behind it was actually from this executive order 14028. And that executive order came from the United States federal government, the president, saying that we needed to have more transparency and our software. And the main reason there, the big incident that happened that spurred this very reactionary executive order was the log4j that happened well, probably five years ago, maybe, I believe what it was. I'm sure many of you, if you've worked in operations, were very familiar with that, with the scramble that happened to patch those vulnerabilities or even to discover them. And that's kind of the reason why the SBOM came into existence. Was, wouldn't it be nice if we had a better an easier way to tell if we were vulnerable to this particular CVE, which would be the log4j. So there is a big push from the federal government in the United States to have the SBOM and to develop it. And so that's kind of sparked a lot of down chain effects. It's interesting to note that this isn't kind of a bottom up or a tech industry driven thing um, that's come into an innovation. It's really kind of a reactionary thing that I see from what I've read so far, that it's going to become more and more important, especially if you work with federal agencies. This SBOM is going to be a requirement. So now that we have kind of an idea, at least a vague idea of what it is, let's dive more into its purpose. So the primary purpose, this is probably the most concise definition that I came across lately, which was the primary purpose of it is to uniquely and unambiguously identify the components of in software and the relationship to one another. Um, the rest of them kind of go into more details about the metadata that consists in that, but that's the main purpose of the SBOM. Now, the next thing that I found pretty interesting is what they're used for. So they can really be bracketed into these kind of three. Let's just make this highlighted here. Three different buckets that you can think of what they would be useful for. So the main one is, and the one that I'm really focused on understanding, is the management of vulnerabilities. So the biggest benefit that I can see currently to having an SBOM with your software is it doesn't fully replace, but it augments vulnerability reports. So instead of, say, you had an SBOM generated at the creation of software, you could actually use that artifact to identify which things that you're vulnerable for. Now, it's a point in time scan or a point in time generation of what's vulnerable. So if anything changed in your software and you didn't regenerate the SBOM, it's no longer accurate, just like a vulnerability report would be no longer accurate if you are taking results from 2 months ago and you were trying to assess what your vulnerabilities are now, because there might be new vulnerabilities that have been identified. But the biggest benefit here would be you have some source of information to identify vulnerabilities from and to manage those vulnerabilities. The other one would be software inventory, with just what is inside the software that I'm using. And then the third bracket that is useful is licenses. And so where I see this becoming kind of useful in the future is with other tools that sit on the right side of kind of the software development lifecycle. And that would be a tool called Ratify. So I know that the Ratify team, which is an open source project, they're working on verifiers. So if you're not familiar with what Ratify is, it's an admissions controller for Kubernetes. So it'll let you create these different verifiers and configure them, and then it will reject upon admission different deployments or containers that don't meet special requirements. So, for example, I've used it in my demos previously to reject container images that aren't signed. And so they're working on verifiers that will look for the existence of an SBOM, or they will look for the existence or non-existence of specific licenses. So another reason why the SBOM would be useful, in my opinion, the two most useful use cases would be the licenses to make sure you're not deploying any software that is against some kind of policy that you have. And then the vulnerability management, so like you could say, hey, we don't want anything that is vulnerable to this particular CEV to be deployed. And you'd be able to tell that with the SBOM that's been generated. So the vulnerability management here, there's a key point is because it's a static artifact, static data, it doesn't fully replace the need to have vulnerability data or scan reports from that. But what I'm curious to learn is, can I use the SBOM to do something like I would with Copacetic, which would be, okay, I have these scan results. Can I take this artifact and patch based on that? So that's something that I'll dive into in this series on SBOMs. So that kind of dives into its purpose and what it's used for. And we've talked a little bit about the benefits. I found this neat table. I won't go too much in, but it really depends on your perspective if you're a developer or if you're the organization. And so here's just a diagram that kind of highlights, I guess, for the lack of a better word, some of the advantages. So less unplanned work because you kind of know your vulnerabilities quicker, supposedly. But I haven't seen a lot of tooling yet exist on, okay, I have all these SBOMs. How do I get like a single pane of glass across my infrastructure to see what's vulnerable? That we have some of that with vulnerability tools, but I've not yet seen that with the SBOM. But reduce security risk and all that stuff. But I won't go too much in that because, not too concerned about that yet. I really want to figure out how it is that I can generate them and use them. But what another interesting fact that I'll leave you with here is, what information does it contain? And so I ended up reading this SBOM minimum requirements report. It's like 30 pages. And it was helpful, but hopefully I can summarize it here for you and save you the very dry / riveting read that I did yesterday afternoon. But there's kind of a 4 main minimum pieces of information that you want to have included in your SBOM. The number one is the data fields. This makes the most sense. Yeah, so the majority of these are to express and enable the mappings of sources of data. So inside the data field, this is kind of what you would typically imagine inside of a kind of a software inventory. When it's generated, the tool needs to support whatever tool you choose. We'll get into that in a second. There's a lot of different ways to generate these SBOMs. You need to have the supplier name, so it'd be the company that wrote the particular component. The component's name, so that's just whatever piece of software, whether it be a package or a layer in a container or the base image of a container. That would be a component, which gets into the different types of SBOMs we'll talk about just a little bit later, like in container SBOM versus kind of your code, the source SBOM, the source code SBOM, the version of the component, some other unique identifiers, which is interesting. You can use different unique identifiers like the SWID ID or the package PURL, the package uniform resource locators. All this is just going to be metadata that's inside of the SBOM. You want to have as a minimum requirement in there, the tools should support the dependency relationship. So, is this a dependency for X and Y software, and how does that all map? And then the author of the SBOM, which would be whoever's generating it. Ideally, in this case, would be you. And then timestamps, so you can have an idea of how old the information is or how new the information is. So that's underneath the category of data fields, and that's the primary information that's stored inside. But it is good to know that there are these other minimum requirements that you want to have around it. Automation support basically just means pick a kind of an industry standard format. There are some winners in this category, at least 2 of them. So the SPDX, the software package data exchange, that is a popular format for SBOMs. And you'll notice when we get into talking about the tooling that SPDX and then the next one, Cyclone DX, are the most common. And there isn't a single format. And the reason is they wanted to provide some flexibility. So if you read the spec and if you read the document here, this minimum elements, they wanted to provide some flexibility and not mandate a particular format because it's very evolving in an iterative process, as they say in there. And so often the tools that you use to generate these or to consume them to generate reports from, vulnerability reports, will allow you to convert between these types. So that's good to know. And then software identification, this what is also a type of form of automation that's inside of there. Now I'll talk a little bit about the practices and process that I found. So this is probably the grayest area that I came across in my reading, which is, like what do we do with these particular SBOMs? And so some minimum things that the documents encourage you to think about is to have some practices and processes around when you use them, or some contracts between customer and vendor and so forth. The number one is the frequency. Like, when are you going to generate these? Ideally, you'd probably want to generate them inside your build or release process, which kind of dovetails into another question I haven't fully answered, which is where they're stored. So far, what I've seen is people will store them in their release as just another artifact that's inside of the documents with their container image and their binaries. And then another would be to attach them to a container registry inside something like an image index, as an OCI artifact. But anyway, you have some kind of idea of the frequency at which you're going to generate these things. And this is all under the practices and processes. Um, Give some thought to the depth. So a lot of times the tools themselves will kind of pick this for you, or you can specify when you're generating it. At a minimum, you want to have the top level dependencies. So, like, what's my software, and then its dependencies, which gets into the known unknowns, which essentially means, okay, I have this dependency, but I don't know what it depends on. That would be a known unknown that you would want to declare in your SBOM when you're giving your SBOM to another entity, your customer perhaps. And then distribution and data, where are you going to have these things stored? Are you going to have them as part of the software package that's going to be bundled and delivered to your customer privately, or are you going to have it publicly available on, wherever they pull your artifacts from? And that kind of makes good sense if you're if you are on GitHub and you just want to put it in your release, or you want to put it in the registry and then use like the refers API inside of the OCI container registry to point between those artifacts. And then have some mechanisms. So this is all from the perspective of the publisher, from you if you're creating them. Have some kind of practice to accommodate for mistakes that allow you to correct errors and omissions inside of your SBOMs. Again, a lot of this has been kind of abstracted and handled by the tooling, but you'll want to have some idea, it looks like, moving forward, of like how you're going to be generating these. I think that's all I have for understanding, but yeah, that's, I don't know, probably half a day's worth of reading, shoved into 15, 18 minutes. That helped me at least figure out, what is this thing? What is it used for? But if we go back in here, let's see where I am in my research for this. Let's start tinkering around with some of the ways that we can generate it. Now we've got a better idea. Oh, let's talk about this real quick. Let me pull this up. So I found this article. Let's make this a little bit bigger, about the different types. So really all of the tools are going to be on this analyze. So if you take a step back and you think about what are the different things that I could potentially create an SBOM from, the two big ones that kind of pop up in my head would be, okay, well, I have my application and I have some dependencies in there. Say I'm writing a Go application. Maybe I'm pulling in some packages from GitHub. And so my Go mod file has a list of all those dependencies. And so I could generate an SBOM from the language's perspective, from the application, the source code. And so that would be here or inside the build process. But then there's another artifact that I'm potentially concerned with, which would be my infrastructure. And if you're using containerized deployments, it's a little bit more simplistic to generate. And a lot of legacy, the disclaimer here, they don't have methods to auto-generate SBOMs for kind of legacy. Maybe you're doing bare metal or something like that. I don't know if there's tools that would do that. They would, and if you do, they would be under this category of analyzed. So most of the tools out there, what they're doing is they're analyzing some kind of artifact that's generated, that you have, and they're using third-party tooling to create the SBOM report. So if you have a container image, these tools analyze the container image, find its dependencies, and generate the SBOM based on that. Sometimes it's built into the tool itself, like the build tools for the language, and it's mainly just worried about generating the SBOM from that language or the source code. And then you can combine them. And those are all questions I have yet to answer, which is there a tool that can analyze all of that and generate me one, or do I have to have multiple tools that generate SBOMs and then kind of consolidate them into one tool? Those are questions I don't have yet. But now I kind of want to spend some time installing tools and kind of tinkering around with it and see if I can't get it added into my environment. So we'll focus on this part. So like I said, there are kind of 3 top ways of generating these right now, at least that I found. Docker recently added support for them. But what I want to start with is Trivy, because Trivy I've been using already with Copacetic. So if you're not familiar with, let's pull that up. Copacetic, a super cool open source tool. Oh, went too far. That's been gaining some popularity. And essentially what it does is it lets you take Trivy scan results. And you can see the little demo here. It lets you take scan results and then at least the OS level right now, patch them. So that's pretty neat. And my ultimate goal here would be, can I do that same process for an SBOM? Can it read it just like it does a Trivy report? Because eventually I believe this tool will be able to patch application vulnerabilities. Now, a lot of people kind of say, well, like, why would you ever patch a container image? Why don't you just rebuild it? Well, that assumes that you have the ability to go and kick off a new build and control whatever it is. But you might have a dependency from an upstream container image that maybe they're not moving as fast as you'd like, or you have kind of a version lock that you can't move to the next one without some kind of code changes. And so in that case, it might be a good idea to kind of create your own tag of that or version of that container image and patch it on your clusters. And so this tool is really handy for that particular thing. So yeah, let's just dive in and tinker around with Trivy, because I figured out so far how to generate the SBOMs. I haven't figured out yet how I'm going to attach them into the GitHub workflow, but I've found some examples. But yeah, we'll just spend the remaining time here playing around with the tools. If you're not familiar, let's just kind of browse through this code. I have a GitHub repository. Well, let me send a link to this if people are curious to play along. That I spent a lot of time kind of automating the build process for a lot of this stuff. So let me just find, there's my search bar. There it is. I'll drop a link. So here we go. Comments, banners. Here is the repository. I'll just put that up on the chat there. So it's under my GitHub account, Secure Supply Chain on AKS. And there is some documentation. So if you want to work through the workshop, and then there's a bunch of scripts and stuff to set this up. But essentially what this does is there is some Terraform. Gotta love some Terraform. That sets up the entire environment with a workload identity. So it sets up an AKS cluster, an ACR, so a container registry, sets up the workload identity so they can talk to each other, and sets up ratify and all that good stuff deployed on here. So there is plenty of documentation that shows you how to do it manually or how to use the automation. That's underneath the docs, so you can get the exact environment that I'm doing here, or that I have here. And then I have a sample app. Once all the infrastructure is deployed, I'm just using a version of the Azure voting app, probably familiar with. It's just the page where you have 2 options to vote, and it uses Postgres, and it's written in Rust. So there's like a web UI written in Rust, and then there's a Postgres database that stores all of it. But I'm using that as a sample app. I've been meaning to replace it with my URL shortener that I wrote in Go a while back. I just haven't gotten to it. But anyway, this gives me a nice playground where I have the infrastructure built that I need for this, and then I have the application, and then I also have this workflow. And so I just want to briefly go over the high level It probably will make more sense if I look at it from the GitHub perspective. So if we look at the secure supply chain on AKS on my GitHub account, we'll look at the actions just so you can see what I'm trying to modify. So if we look at the build, here are the top level steps. Again, all this is pushing out to Azure and to AKS, of course. But at the highest level of the workflow, what I'm doing is I am checking out the code. I am logging into Azure in the container registry. I am building the Docker container and pushing it to the registry. So I'm building the Azure container app in Rust, pushing it there. And then I'm scanning it, patching it with Copacetic, and then I'm pushing that patched version. So I'm moving, patching, scanning and patching all on the left side. There is a more common pattern where you have a separate job that scans and patches containers that just exist in your registry and they're not necessarily part of your pipeline. But I'm also signing that container image and pushing it up there, and then all that good shenanigans there. So what I want to do here, though, is I want to use the SBOM tools. I don't know which one yet, if I'll use Trivy or if I'll use something like Sift. Sift's a very common one we'll take a look at. But essentially what I want to do is generate an SBOM and include it with this application. So then I can use it to inventory the software in there or potentially use it for vulnerability scans instead of the Trivy results. Maybe I'll need to use both. I don't know yet. That's kind of where I'm at. And yeah, I know I've been rambling and talking, but any questions you've got about this, if this is, I'm curious if it's even something on a lot of people's radars. I hear a lot of noise about SBOMs, but that just might be kind of the space that I'm in because I've been kind of swimming in the secure supply chain space for a little bit. But I'm curious if anybody out there, if their leadership is asking them, or if partners or customers are inquiring or requiring this particular artifact to be included in your code. So yeah, let me know in the comments. But with that, let's take a look at Trivy. So I think I found some good docs. Actually, we'll just take a look at the command line tool. Oh, no, don't do that. Let's open up the terminal. There we go. So I have in my install script, if we look, install dev tools. I'm on a Ubuntu dev container. If we look for Trivy, here's what I'm doing to install Trivy. But they've got great documentation on how to install. I think they have brew support and maybe even WinGet or Chocolatey. Thanks for a comment, Adam. New to you personally. Well, hopefully it's useful. All right, so now that we've got that, I know that I've got Trivy installed. There, we've got to figure out how to generate it. And so if I remember right from the documentation, I'll pull up over here so we can see it. This is SBOM scanning. There is the Trivy SBOM, but this kind of tripped me up at first. If we look at the help for that, Trivy SBOM help. This is actually used to scan SBOMs for vulnerabilities. I thought that this would generate it, but it doesn't. This is for the kind of the latter end of it. And to actually create it like that, you have to use the image command down here a little ways. Image, and then you specify the format. Again, here's where those formats come into play. And a lot of these tools can use them interchangeably or even convert between the two. But the most common are the Cyclone DX and the SPDX. So these are just the data formats. I think these are both JSON documents, but it's just how it's formatted. They're going to be a little bit different. But to generate it, we have to do something like this. We have to change the format, because if you do it without the format, it'll do Trivy's scan report. I believe it has its own format, but we can specify this in our command. So if we go back to VS Code, I'm not using my NeoVim set up just yet because I haven't figured out how to integrate dev containers, and I heavily rely on dev containers for this particular repository. But if we do Trivy image, and what were some of the options that we needed? The format. -- format. And I want to use the Cyclone DX. I don't want to use the SPDX. And if we look at here, I think it's just this Cyclone DX format. I think it was the image that's next. Let me just split this. Yeah, I'll just keep switching screens. Format, SPDX, maybe it's Cyclone. I wonder if we can do help here and it'll stop the formats for us. Find format. JSON. There we go. Cyclone DX is the acceptable format. So we'll put that in there, and then we'll do an output. And we'll just name it Cyclone DX.json. And the last bit is, oh shoot, it's going to be the image we need. So let's just copy this and take a look at what images I've got on the system. Images, that's what I need. So the image for this sample app that I've got is Azure Voting App Rust. And I want to specify version 0.1 alpha. That's the version that I pushed up to ACR with the last GitHub action release that has a signature and stuff. Oh, I probably need to do sudo and install it with one, but just make sure that this is not residue from the first time I did it. That exists. Let's bring this up. Oh, where did it go? Oh, I gotta minimize the terminal. There we go. Here's the format. It tells us the BOM format. So the SBOM format is Cyclone DX. And then we have a schema version. And then in here, the name of the component, and it's a container. So I'd imagine if we were scanning, the SBOM tools can also scan source files. And I bet that would change. So I could scan just maybe the Rust directory, and then it would have an SBOM specific to the source code. We should check that out next. But then it's going to have all the components that are inside of my container image. So now that I have the directory, oh, there it is. Cyclone, it's SBOM. I should probably named it SBOM to be more clear. So let's do that. Expected. Let's generate it and call it the SBOM. Now we've got the SBOM JSON. Okay. So I should be able to use that just like I would a reports JSON. If I open up my demo script, I have a way to generate that. I just want to compare the two. I wanted to use the Trivy scanning results and then the SBOM and see if I get the same vulnerability data back. Here we go. And I want to output. The name. this. JSON. Okay, so now I have a scanner, a vulnerability report with patch JSON, and then I have the SBOM. So let's use the Trivy SBOM. Move this here. I should be able to scan it by just pointing it at that SBOM. So Trivy SBOM. So I need to do sudo. Just the severity ones. Just count the critical. I've got 15 from the SBOM. Let's just see if we get the same results from the patch. We probably need to outputting it. Let's just shell. Sweet. Okay, so the SBOM would totally is at least when you generate it with Trivy, which makes sense. It should be kind of a 1-for-1. So that's how we do it with Trivy. There is another tool. So Trivy is kind of like an all-in-one. I'm not sure if it's a benefit or kind of a negative aspect, but we're using Trivy to both generate the SBOM and then we're using it to scan just with one tool. That's not typically what you see. Typically what you see is there's two different tools. So another really common one that I ran across was Sift. So let's just bring Sift over here. Might need to just maximize that for a second. So Sift is another open source tool, and it works with another tool, an exception, a vulnerability detection scanner called, is it Greif? Graph. That's probably how it's pronounced. So Sift will create it, and then this will scan it. Two separate command line tools. I believe they're, from Anchor. So they're both from the same company, by different tools nonetheless. But I believe this supports, like I've mentioned before, Cyclone and SPDX. And then there's, I guess, Sift has its own format too. One thing that's cool to mention about Sift, at least with the Anchor stuff, is they have a GitHub action that I could kind of hook in there. So let's install this and see if we get different. I assume we'll probably get different results, but we'll install it with Bash. Another beauty of dev containers is I can just install random stuff and then I can rebuild it, and if I don't like it, it resets, which is fantastic. Probably need sudo. Failed to install, permission denied. Cannot create file, even with sudo. Nix package maintained. Is there a manual installation step? Hmm. Maybe it's protected. There we go. Oh, we have Sift. We have it. All right. Let's take a look at the help Sift. I think Sift can do both container images, but also the language. I think it had some examples. Sometimes the docs are more helpful than the help system built into the tools. Get started. Image. So let's scan the image. Let's start with that first. Get the right program open. Into a variable. That's got a nice interface to it. I wonder if it's using Charm under the hood. Okay, so that found all of its stuff from the container image. A lot of that looks very similar to what Trivy found in the image too. But how do we make it export? Scope all layers. That's cool. You can scan tar files, archives, and directories. But how do you save the results? Default scanner config. Output formats. Out format. We can do Sift JSON. Here's this like Cyclone DX JSON. Let's try that. We'll call it SBOM2. The output -O. That makes sense. O format. Is that all? We don't need to give it a name or anything. Okay, that just outs to the console. Not as helpful. Center. File to write the default report to. Use output. Where's output? Output string or array. Formats. Okay. Out to file. Format file. Is there an example of that? Let's don't really care for that. Maybe this has an example. No. If you got any ideas, throw them up in the chat. Directory. output. Oh, here we go. Oh, multiple outputs. I don't necessarily want to do that. Oh, here's how you do it. So we want to do equals SBOM2. So we'll do Sift. SBOM dot. Interesting that it didn't format it in JSON or recognize it. Oh, set format. Okay. That makes me wonder if I'm not doing that correctly. How are we doing on time? Oh, we're getting close. Getting close to the hour mark. That's where we'll wrap it up, maybe. We can generate with Sift. We can generate with Trivy. Let's see what graph gives us. And I really don't, to be honest, I really don't know what the advantage would be of these different tools. You know, maybe if one gives you more detailed information or lets you go deeper than the other one. I don't know. Where's installation? That. Okay. So argument. Check out this tool. Verify the artifacts. Checksum. We can use cosine. Another signature tool. Image. So we can scan the image directory, or we could use the SBOM. So the benefit would be you've got images out there, and you could, I guess you could collect all the SBOMs and scan them instead of scanning, like say you had a, I don't know, a pod run of like 6 of these different containers. Instead of scanning all 6 of those, you could just scan the SBOM that came with the container image. I'm not sure. But this is supposed to generate the vulnerability report like Trivy does. Or file systems. Vulnerability scanner. Let's just take a look at it. So do I still have that variable image? Yeah, okay, so gr image. Does Sift do anything more than generate? No, it's specifically for SBOMs. A CLI tool and Go library for generating software bill of materials. Well, that means that I could probably build this from scratch. That would be interesting. Exceptional for vulnerability detection when used with scanners. Okay. I really like the way that this outputs to the CLI. 15 critical. Okay, so it's got the same number as Trivy for critical. So at least there's some consistency there. maybe I'll try to use this for Sift in this tool for the pipeline. So how do I use this though with the SBOM? Have an example? Well, I didn't want that. JSON. Oh, I'm on the Sift documentation. No one told me this. Maybe you just point it. There we go. SBOM. So it has an SBOM subcommand just like Trivy does. So let's see if I messed up my export. So GR SBOM. Oh, you can pipe them together. That's super cool. That way you could save an artifact, but you probably want the SBOM attached somewhere, not just a vulnerability report. All right, let's try it. Sift. It's 2 arguments. What I saw. Path to SBOM. Oh, it's okay. I'm doing the formatting wrong. Oh, okay. I'll put it correctly. I just didn't VS Code didn't recognize the format. I wonder if I can. So 15 critical. Can I filter by severity on this? Severity maybe. Fail on severity. Wonder how you filter it. That's pretty cool. Well, unknown here is I don't know if Copacetic can use this output. But I think my next question that I have to answer is where do I want the SBOM to be stored now that I can generate it with multiple tools. The other way, let's dive in. The last way that we'll do before we wrap up the stream. So I'll leave how do we add it to the workflow? Didn't quite get to that today. But I think the last thing we'll look at is I think Docker just introduced some tools where you can generate it with build kit where you wouldn't need, if you were using Docker and you had Docker images, you could just add the SBOM with your Docker container image. Let me pull up that. I think I have it right here. So we'll wrap up on that. So at least this stream will have kind of captured 3 different ways to generate 3 different tools. And then in the next one, what I'll do is kind of dig into, do a little prep work and research and figure out, once it's generated and inside of the workflow, what do we do with it? Do we want to put it inside of a release and only have the SBOM generated when the software goes into a release inside the workflow? Or do we want to attach it to something like the container registry as a OCR artifact and do it that way? Because I think the example that I was going off of, they use the artifact, but I don't know what the advantage and disadvantages yet. So I'll do some more research and we'll come back for that on the next stream. Who was the gentleman that reached out to me on Twitter? Shout out to him for showing me this. I think it was containers. Yes, Felipe. This gentleman here. So he's a software engineer at Docker. He follows me on Twitter and recommended this blog post, which is pretty cool. But essentially what this lets you do, and I wonder what formats it works in. We use Cyclone. The Cyclone mentioned. So maybe it's SPDX. But anyway, what this allows you to do is generate the SBOM with Docker commands. So all those other ones that we saw, you'd have to install Trivy or you'd have to install Sift. But if you're already using Docker and BuildKit, which is built into Docker CLI now, I think for a while, looks like version 0.10 BuildX 0.10 release, which I think I'm on, like, I think it's on 24 now, 25. Could be wrong. How do we use it though? So let's just check our build kit version, and we will split screen again. Hopefully that looks like a decent size on the recordings. Hopefully that's not taking up too much real estate. We'll figure this out and we'll wrap up this stream, and then we'll work on adding SBOM in the second part. So let's just close that. Don't save anything. Terminal. Actually, I think we need the Docker file open here. So this is the Docker file that containerizes the Azure voting app, which is that image that you saw on disk. So I want to just check to make sure that I have enough version on here. 10 unknown. And that's because it's sharing with my host because I'm using Docker container. Version general. Should be good. One second. Okay, latest and greatest. I think I'm on a version high enough, potentially. I don't know how I'd upgrade Docker inside my Docker container. If not, we'll just switch over to my local instance of Docker on my Windows machine, and we'll generate it from there. So you add the SBOMs by adding in this tag. Adding SBOMs to your images. BuildKit generates SBOMs using scanner plugins. So it actually uses Sift. Is built on top of Sift. So you can use, all right, let's check that out. BuildKit image tools. Our image. Not sure why I need sudo for all this stuff. Not authorized. Insufficient scope. Is it not scanning it locally and it looks for it? in a repository. Oh, also works local here. Okay, so yeah, it's trying to, and obviously doesn't exist. Well, I'd have to put the ACR name and it would work, but I want to try it out locally. Image. Build. SBOM true. Oh, so it's actually just trying to build it. Am I in the right directory? Should be able to point to the local directory and not even have to point. Oh, it's going to output. Output. Oh, outputs it in the image directory. Okay. Why not just have it be here? Okay. So apparently the version of Docker inside of my dev container does not like it. So let's just open up a new terminal and we'll use this terminal for that. This command. Here we go. And good old PowerShell. Let's go find that command. I'm curious what version I'm running on. Here we go. Okay. Yeah, so I've got build kit. I wonder how I'm going to upgrade that inside my dev container. I'll have to worry about that later. So if we want to generate the SBOM locally with the build tools, and it's going to use the Docker image for that. This. I don't think I have an image directory. Build the open Docker file. Build kit mount no such file or directory. Also works with local tar exports. Oh, well, I don't have tar exports. On push, you can build and push the image alongside. I wonder how you just generate it locally. I suppose I could push it up to ACR. What's this do? Image inspect. Here's how you generate an SBOM. Okay. I have that in here though. Here. Let's change into that repository. Docker. build. And then we'll grab that name from in here. Putting app Rust version 0. Alpha. Yeah, it might take a minute. I think it's a little bit of a long build. So you can, I'm just trying to rehash on this. So you can build it when you push it to your repository. You can make it include an SBOM. And I wonder if that's just putting it with the Docker, like the container manifest, or is it storing that? And it says you can do it locally by BuildKit generates SBOMs by using scanner plugins. By default, it uses the BuildKit Sift scanner built on top of Sift open source project. If you like to use another scanner, you can change that. Here's how you view generated SBOMs using BuildKit. Okay, so that's only going to view it once it's generated. Also works with local tar exports. I'm not doing that. I just have an image. This was the main thing I wanted to try, was you can actually just put in tags or different arguments rather. So then when you build, it will generate the SBOM. Let's try that out. It puts that in underneath the from. BuildKit SBOM scan stage. I have two. I wonder if I need it in both. Do I need it in both layers? Okay, because this is a multi-stage build. I've got a builder, and then what I'm actually running it on. To the finish. Almost. Okay, there it's done. Let's rebuild it. Now that I've enabled the SBOM, how can we inspect it? Docker BuildKit inspect. It's still active. It wants me to push it. I just want to scan locally. For local and tar exports. So I would imagine that means local image. Docker build X. SBOM true. Oh, let's see, output, and then the current directory. Just create the image directory real fast. See what happens. That's probably tiny. Yeah, Linux shell. All my things aren't working. All right, so Docker build x SBOM true. Docker build x what? Oh, build. I'm missing build. I think this is supposed to output the SBOM into the app, that image directory. Oh, cool. It's error expecting client library. Failed to. I have no idea what that is. Image bin. In here. Interesting. It needs to be run as admin. Weird. Power Toys doesn't like that. So CD, GitHub, secure supply chain. Let's try that out. I think I get the same result because it must be something else. Failed to resolve. Cancel exporting client directory. Wonder if we remove these, still generate an SBOM. No. Okay. Might be because I'm trying to build it on Windows. I don't know. That's my guess. Well, at least we know how to generate it with two different tools. It would be nice. I'll spend some time tinkering here with the build tools, but I don't even know if they're available inside the runners. Like, if you're using a GitHub workflow, because that's the ultimate goal there. I might stick with Sift because that seems to be what everything kind of picks up on, or see if Trivy might have a GitHub action. Yeah, it's a good place to stop. So we at least know how to generate some with some different tools. We've learned about kind of the background of it, why SBOMs came about, the different formats that we've got available to us. The SPDX and the cyclone seem to be very common, and then you can actually convert between the two. That'd be something to kind of test out to see if we could do that. Yeah, so in the next one, what we'll do is we'll kind of finish this up. I'll work on doing some research and making sure I can get it to run inside the pipeline. Let's see where we put it. If we put it with the release, or we put it with the OCI artifacts. Let's see. Let's just stop presenting here. switch to the main screen. Yeah, well, thank you all for tuning in to this live stream. Hopefully this was somewhat useful for you to understand kind of the SBOMs. Let me know if you got any feedback, if you like just kind of going over the notes, if you want to dive more into like how I collect research and so forth. I'll probably end up turning that into some kind of a blog post just to kind of crystallize my understanding. But even these live streams are super helpful for me just to kind of um, rearrange the knowledge in my brain, so to speak, and kind of share it and teach it a little bit. Yeah, next time on the next stream, probably next Thursday, what we'll do is add this to the GitHub action workflow itself and figure out where to put the different SBOM. But I think I see some of the promise of it. I know the tooling really isn't there, but if I had a way to kind of look at my infrastructure and basically extract all the data in this and see where the vulnerabilities were without needing to rely on a scanner, because scanners have their own problems. We'll just put it that way. But if we had some kind of tool that we could trust that says, hey, here's what's in the software, and then there was something on top of that to give me a view into it, I think the SBOMs could be super useful beyond just something that's being mandated or required with the software. So I see some use case in there, but the tooling does seem to be a little bit, I don't know. There's a lot to it, but maybe this complexity will go away with time. Sometimes you just gotta kind of let it wash over you, so to speak. But yeah, and enough of my rambling. Thank you all for joining in, tuning in. Super grateful for all the support for everybody who wants to watch this. Hopefully this is useful. Love some feedback. Leave some feedback comments. Even if you're watching recording this, let me know what you thought. But thank you so much. See you next time.